Understanding the vocabulary used in probability will help us to express ourselves in this topic. Experiment, outcome, event, sample space are some of the most important terminology in probability. It is better to explain these in examples. Example 1 is about throwing a fair die. At this step, it is important to mention that sometimes you may see unbiased instead of fair. These are the cases when there are equal chance of getting each number on the faces. In some cases, a die may be weighted or biased so that each number has unequal chances to happen. So in example 1, let's read it. A fair die has each face numbered 1 to 6. The die is thrown once and the number landing face up is recorded. In this example, rolling a die is an experiment in which there are 6 possible outcomes. So the outcomes are 1, 2, 3, 4, 5, and 6. In probabilities, an experiment is a process in which there are one or more possible outcomes, each of which depends on chance. Given an experiment, the sample space consists of all the possible outcomes of the experiment. It may be written as a list with capital letter S or capital letter U, as a diagram, or as a Venn diagram. In this example, we are rolling a die, then we can identify the sample space by a capital S and listing the outcomes like this. So let's read part A. In part A, we are looking for the probability of landing the number 5 face up. So, landing with number 5 face up is a single event with only one outcome, that is 5. So, out of 6 options, there is only one 5. And out of 6, the probability of having this 5 out of 6, there is only 1, so 1 over 6 is the probability value for part A. In part B, we are looking for the probability of throwing an odd number. So, throwing an odd number is an event with 3 outcomes. So, odd numbers from this sample space are 1, 3, and 5. So out of 6 options, there are 3 odd numbers, giving us a probability value of 3 out of 6. And always cancel your fraction, which is 1 over 2. I would like to give an information about coins. Every coin has 2 sides, as seen in the photo. This is 2 sides of one coin. On one side you see the price, and that side is called tail, and the other side has a picture, and this side is called, the pictured side is called head. In example 2, the experiment is tossing a coin, and all possible outcomes are head and tail. So, sample space can be listed as H, which is head, and tail, the capital T. And getting a head is an event with one outcome. So, part A, probability of having one head is 1 out of 2. In part B, we are looking for the event getting a tail. So probability of tail here is out of 2 outcomes, we have only one tail. So it is 1 over 2. In example 3, experiment is tossing 2 coins. And all possible outcomes are, so if I have coin 1 and coin 2, and the possible outcomes can be like this. If I have head from coin 1, I can have head from coin 2. If I have head from coin 1, I may have tail from coin 2. If I have tail from coin 1, I may have head from coin 2. If I have tail from coin 1, I may have a tail from coin 2. So sample space has 4 outcomes: head head, head tail, tail head, tail tail. So we are looking for the probability of getting 2 heads. There is only 1 out of these outcomes is 2 heads. So out of 4, there is 1. So this is the probability of having 2 heads. In example 4, experiment is having sum of the numbers indicated on 2 spinners and which are thrown together and having 4 faces numbered from 1 to 4. And in this case, we have many possible outcomes. That's why listing them may not be very practical. So sample space diagrams are useful in those cases, as it is drawn here. On horizontal and vertical axis, label the outcomes of the spinners. So their combinations are written as their total, like plotting the coordinates on Cartesian plane. So the outcomes of spinner 1, 1, 2, 3, 4, outcomes of spinner 2, 1, 2, 3, 4, and each of it meets with the other like that. So 1 and 1 meets here as 2. This is the total of these outcomes. I add these outcomes because the question says so. And another one, 3 and 2 meets at 5. So there are, in this way, you fill these spaces, and there are 16 possible outcomes in the sample space. These are all possible outcomes, 16 outcomes. In part A, event is sum of exactly 5. So go to your diagram and see how many 5s in it. So there are 1, 2, 3, 4 5s out of 16 options. So part A has probability value, which is exactly 5, is 4 out of 16, and always simplify your fraction, which is 1 over 4. In part B, event is sum more than 5. So go back to your diagram and see how many sums which are bigger than 5 in it. So these are the sums which are bigger than 5. So 1, 2, 3, 4, 5, 6. There are 6 of them out of 16. So part B, probability more than 5 is going to be 6 out of 16, and cancel your fraction. 3/8.